Okay, so what you're going to do is, and I have some of the, I have the beads, I'm trying to get it to show up better. You're going to have a paper bag with some beads in it. And you can work with a partner. And so if this is, the bag, and you put some beads in it. And the experiment is that you're going to mix up the beads each time. Probably one person will reach in to the bag and pull out a bead. And then you're going to note if it's red or not. Well, pink is not red, so that's not. You're going to do that 8 times. It's important to put the bead back in the bag. Mix it up, reach in, take another bead. And that is another one that is not red. Okay, that was blue. So, and you do that 8 times. So suppose and put the bead back. Suppose I got suppose I got 2 red beads and 6 that were not red. Then my odds of getting a red bead would be 2 to 6, which I'd reduce to 1 to 3. Don't write this on your paper though, because this is not necessarily what your numbers would be. And the probability of picking a red bead based on what I just did, based on this experiment, the probability of picking a red bead out of this bag is going to be 2 out of 8. 1/4 is 0.25. For if those are the numbers I got. And then you're going to continue to run the experiment 20 times. So you're going to add, you can use these 8 and just pick 12 more times. And then you'll figure out your probabilities. This time the probability will be over 20. And then you're going to do, that's 20. Do another, you don't have to do, you can use the previous ones and do 20 more times. So this will be, the probability will be over 40. And this, what you're doing is you don't know the sample space. You haven't taken the beads out and counted how many red beads are here. So what you're doing is you're doing the probability of event A is frequency over n. Sometimes we don't know our sample space, so we can use frequency over n as an approximation to probability. That's an approximation to probability. It's also called probability. It's also called empirical estimate, experimental or empirical. This is what you're doing. You're using frequency over n. You're doing an experiment, and then on the second page, well, then you'll talk about which should be the best estimate. They're all estimates. And then on the next page, you're going to carefully take your beads out of the bag and put them on a paper plate. Don't just dump them. They're going to go all over the place. So you're going to have to maybe reach in and take them out and put them carefully on the plate. And then you're going to actually sort them and count the number of red beads and count the beads that are not red. And then this will be your true probability or the classical probability. And I don't know how many beads are in my bag, so this is a classical method. This is the true probability. Its probability of an event A is the number of ways A occurs, number of ways A can occur. Over N, the number of equally likely ways of equally likely outcomes. So if my bag has 100 beads in it and 50 are red, this number would be 50 over 100 or half. But it's the true probability. So this experiment is to help you understand the difference between true probability and experimental probability estimates. Okay, so, and then we'll stop there. Bead activity 2 will be a bonus activity if you want to do it later. I'll give you I have the bead, the colors to use posted on in Shelby, I think, for that. So you guys can work in groups of 2 or 3, I guess. So these are my really nice bags here. But so one person from each group can come up and get, and we may run out of plates, I don't know. Come up and get a bag of beads. Somebody can use a bag, yeah. Everybody doesn't need a bag of beads. You can get one for every 2 people, or if you want to work it by yourself, you could. Or if you want to work with 2 or 3. And you can take that one again. Did everybody get some? Okay. Good. And you have to put the beads back in the bag. And if your bag is absolutely falling apart, you can get a new one. You have to put the beads back in the bag each time after you pick it. You're supposed to put the beads back. And then, you know what So what did you think? See, the probabilities in 1, 2, 3 were all experimental. So which one of these would be the most accurate, you would think? Number 3. It's okay if you did 60. It's okay. Number 3 should be the most accurate because we did it the most times. We repeated it. And I want to ask, so the true probability, this group, so which one was closest to the true probability?
It was number 3. It was 0.317 and the actual one was 0.311, so it's really close.
Okay, so you were really close on that. What about this group over here? Which one was closest for you? Number 3 was closest? Yeah. 5, 6, 7, and then your true probability was...
Actually, it's just 6.
The true probability was 460. Okay, 29 over the total. Okay? Look at her. You have to, on probabilities, you had to add it. Okay? You have to, on probabilities, it's always over the total. So there's the close. What about you guys? Did you get this? For number 3 or the true? The true probability was 0.357. What was the closest? Just kidding, I never bought a lottery ticket in my life, and I don't really recommend it. The odds of winning are very good. So this group's got, 1/3 for the true probability, and which one was close, Mary? The third one was closest. Over here, what'd you get? The true probability is number 4, is this. You got 0.29, this is where you put the beads on the bag, and you actually count in the sample space, so you know it's the true probability that you get the red bead out of the bag. It was 19 or 66. So then we compare those to 0.75 and 0.5 and 0.42, and so the third one was close. They were pretty far off, but now what do you guys get? You got 0.36 for the true probability, and then when you compare them, the closest one was 73. Yep. Okay. What did you guys get back?
Our first one was 0.375, and the last one was 0.375, and their actual probability was 0.32.
Oh, okay, so those are both the closest, number 1 and 3. So, maybe we should play lottery. Kidding. Okay. All right, so do you guys understand a little better about probabilities just from doing that experiment? Experimental probability versus true probability. Here we knew the sample space because we took the beads out of the bag and counted them. Of course, I didn't do it, but all right. Bead activity 2 is for later if we have time. We're going to go on and continue with the notes. Let's stop this.